In my previous videos, I've shown you some of the other Festo Meclabs. There are 3 different Meclabs. This is the third one, the robotic stacker, or simply moves a part from one location to another. And as with the assembler, the one that has the compression cylinder, this one is also pneumatic, whereas the conveyor sorter is all electric. So let's take a look at the basic operation of this Meclab. So I'm going to go ahead and connect it up to the PLC. So I'm using the Automation Direct PLC to control this. The program's already in and running. And to start the sequence, I need to press my momentary push button. So it's going to go down, grip the part, raise up, move over, move back down, release the part, raise back up, and return back to the home position. As with all of the Meclabs, these can be reconfigured in a number of different ways. So there could be sensors here to detect the presence of the part. We could be picking up the one half of the part and actually placing it on top of the other half. So any number of different things you could do with this. These Meclabs, I've not done it, but supposedly these Meclabs, you can configure them in such a way that all 3 work together, whereas one is maybe feeding and assembling parts for another station and then doing the sorting down the road. I've not done that. I will show you though in a later video where I control all 3 at one time using one PLC, just to demonstrate that easy capability of a PLC. So let's take a little bit closer look at the Meclab here. We have the I/O block, and with that I/O block we have 5 inputs and we have 5 outputs. The inputs are the push button to signal the start of the cycle, and then we have 4 positional sensors on 2 of the cylinders. So there are 2 on this cylinder, and then there are 2 on this cylinder. The 2 on this cylinder are to detect the retracted position. You can see the light on right now because of this horizontal cylinder being in that retracted position. I'm actually going to turn off the air here. And if I go ahead and move this cylinder out, that'll go off because now that cylinder piston is in some intermediate position. But if I go far enough, you'll see that the other sensor will come on, indicating that that is now fully extended. So we have these 2 inputs here. I'm going to go ahead and turn this around so that we can see the other 2 a little bit better. So let me remove the air, make this a little bit easier to do. And I'm going to leave my cable connected so that we have power to the I/O. Let's see if we can get that in the shot a little bit better here. So we have here then on this cylinder 2 sensors. You'll see that this one is currently lit, indicating that this vertical cylinder is in a retracted position. There's one on this side, so that when that vertical cylinder extends, we'll know that it's now in that extended position. So we've got the 1, 2, 3, 4, and then the push button being the 5th input. You'll also see that we have valves as we did before, and the valves as before are a mix. We have one that looks different from the other 2, but we do have a total of 3 valves because we have a total of 3 cylinders. We have the horizontal, we have the vertical, and the gripper is also a pneumatic cylinder. No sensors on it, but it is a pneumatic cylinder. One of those cylinders is being controlled by this valve. It has a single solenoid on it. It is a 4 two-way valve. The other 2 are also 4 two-way valves, but they have double solenoid control. So with this one, when I energize the coil, the solenoid, my spool and my valve will shift, causing the cylinder to move out of its current position into the opposite position. As soon as I de-energize this solenoid, the spool in here will return because it is a spring return, and that cylinder will return back to its normal position. with these double solenoid controlled valves, or double solenoid controlled valves and therefore cylinders, there are also 4 two-ways. When I energize one of the solenoids, the spool will shift. The cylinder will move into a particular position. When I de-energize it, it will stay in that position because of a detent. When I energize the opposing solenoid, that spool will shift, causing that cylinder to move into the other position. So we have a total then of 1, 2, 3, 4, 5 outputs to control those 3 cylinders. Well, some may ask, why use different valves here? Why not simply use all single solenoid ones? Or why not use all double solenoid ones? And that's a good question. One reason is, obviously if we're using single solenoid controlled valves, the valve is going to be cheaper because we only have 1 solenoid on it, because these are all still 4 two-way valves. It'll be cheaper. Also, we're using fewer I/O. I only use 1 output to control the 1 cylinder. Well, these take 2 outputs to control a single cylinder. So why use the double? There are reasons. One is sometimes the program is a little bit easier to use the double versus the single. Sometimes you want to maintain that detented feature. I don't have to keep this energized all the time in order to keep the valve in that particular position. So if there were a power failure and I were to lose power to my PLC, to my coils, I don't have to worry about the machine moving into some other position. It'll hold that position. And that could be for safety reasons, it could be for other reasons. So there's a number of reasons why we may have this configured the way it is. So that is the 3rd of the Festo Meclabs. I hope you take a look at my other videos. I hope you like what you've seen. Please give me any comments and suggestions as to what you would like to see, how I can improve my videos or my site. Appreciate any feedback that you guys give me. And again, if you like what you see, please subscribe. Thank you.